In this problem, we're asked to find the hybrid parameters for the network shown below. We can see the two-port network shown. We can see the hybrid parameters. Okay. So, for instance, we'll go in and set V2 equal to 0. That would allow us to find H11 and H21. Then we'd set I1 equal to 0, and that allows us to find H12 and H22. So let's start off by setting V2 equal to 0. So here's our circuit, and here's our parameters, 12, 6, and 3. So now we're going to be calculating V11 is H1 times I1, and I2 is H21 times I1. So with V2 equal to 0, now that's a short circuit, and you can see we placed a short over on this side. Now let's go in and let's calculate an R equivalent here, because if we do that, V1 will be R equivalent times I1. So then we'll have I1 times 12 plus the parallel combination of a 3 and a 6. And that'll give us V1 is equal to 14 I1. So then H11 is V1 over I1, which is 14 ohms. And so that was just very simple as finding R equivalent. Now, let's go in and look at basically doing a current divider here at this node. And if I do a current divider, I would get I2 is minus I1. And I want the current through the 3, so I have 6 over 6 plus 3, which is minus 2/3 I1. So then H21 is minus 2/3. Okay, so that gets us two parameters. Now we're going to go in and set I1 equal to 0. Here's our circuit. Notice with I1 equal to 0 that what we've got is we have that first port. We have an open circuit. And now we're going to be calculating V1 is equal to H12 V2 and I2 equal to H22 V2. So if we look at our circuit, here's I2 flowing through that resistor after we do Kirchhoff's current law. So we have 3 I2 here, 6 I2 here. So then V2 is 3 plus 6 times I2, which is 9 I2. So then I2 is 1/9 V2. So if we look, then H22 is 1/9 Siemens. There's the relationship there. Now, by Kirchhoff's voltage law, V1 is 6 I2, which is 6 times 1/9 times V2, which is 2/3 V2. So then H12 is equal to 2/3.